Today's the 15th. It is my younger son's 20th birthday today, so that's kind of a big deal. Uh, and so yeah, I want to get this. I wish I'd have done this before the Y top. As I go through this, I'll be curious to know if you guys remember off the top of your head if you saw any of these on the Y top. So that word, by the way, Parabola is pronounced parabola. All right. And so you'll see right away in our first example what a parabola looks like. And the goal here really is not just to introduce you to what it is, but to give you some background as to why it's shaped the way it is. Like, and you're all good enough at math that this will make perfect sense. So what I want to show you is just the basic, what we call the parent function, and that's just this one. The math we're about to do is off the charts simple. So the best way to introduce parabolas to a room full of teenagers that have never seen it before is to make a table. And you guys, we don't make a lot of tables, but you've made them before. So a table is the thing you use when you just want to find some points on a graph. And so if I want to know some points on the graph, I'm like, okay, I'm going to pick some X's and put them into the equation. And
Good morning, Brock
they will
Nation.
feed me
Still
back some
making
Y's, right?
20.5. Lunch
Okay,
today is
I'll
chicken
pause this.
dunkers or cheese dunkers and PB&J.
Yeah. So as I was saying, this table of values idea, it works for any type of function. You just want to know some points. You just pick some X's and put them in. And then whatever math answer you get is your output. That's your Y. So to teach how to figure out what a parabola looks like, I'll just show you a real structured table. So let's say that we selected 0 as an X value. Put 0 in place of X. What's 0 squared? So we now know that 1 point on the graph is 0, 0. All right, let's say we picked 1. Put in 1, what's 1 squared? So we now know another point. But this is where parabolas become interesting. They're way more interesting than boring little straight lines because what happens when you put in a 2? It's 4. So we see here that this is obviously not linear growth. If it were linear, then it would keep going up at a rate of 1 per 1, right? Which it's not. It's getting steeper. And it's going to get even steeper when we do this next one. What's 3 squared? 9. And so you see now a real pretty precipitous jump. And now what we're going to do, since I'm running out of graph space, is we're going to reflect these X values onto the other side. So instead of picking 1, this is where you really, for the first time, get to see like right up in your face why a parabola does what it does. What happens if you put -1 right where the yellow arrow is pointing? You get +1. Essentially, the negative gets squared off. Like you square a -1 and it flips back to being +1. And now you know the secret. What's -2 gonna square up to be? And what's -3 gonna square up to be? Good. So what we're about to talk about, like for the first time formally, officially, is just what does the parent function of a parabola look like? And it looks like this. I'll use some red dots. And I'm going to zoom in a little bit. Ooh, that was a little bit too much. Um, so here we go. We agreed, you have the table sitting in front of you, that the first point we found was 0, 0. So, this is where the notes are really, really hard to make. And we agreed that, bless you, at 1, 1 was a point. What was the next one? 2, 4. And then look at that jump. And that's where the curvature comes from. And then the next one was 3. And there's where you get to see him. But I mean, if that's all we had, then that wouldn't be a parabola. But then it's that reflective nature. It's the fact that when I head to the left and I square up those negatives, they also shoot up and become positive. So like -1 squares up to become a 1. -2 squares up to become a +4. And -3 squares up to become a +9. So as we go through today's assignment, we're not going to go through and make a table on every one. I just wanted to take 5 minutes of our time together to show you why the graphs are going to look the way they're going to look. And the graph of a parabola or the graph of a quadratic is shaped like this. And it's always curving, which is really hard for people. I'm actually surprised I pulled that one off as well as I did. Making a parabola's graph not look like garbage is really, really kind of tricky. So what we're not allowed to do is like we're not allowed to horseshoe it back in on itself. We're not allowed to graph it like a V with straight arms. Um, You don't want to have a sharp point at the bottom of it, stuff like that. So that's kind of the idea. The only other thing I want to say before I show you how to do what we're doing is, would you guys like to make a guess, an educated guess as to what would happen if instead of y equals x squared, what do you think would happen if we graphed y equals negative x squared? It would be upside down. Well done there, Nashville. And so what happens is structurally the graph is the same. All those things we just talked about are the same, except the points go in the opposite direction. So if we were doing the negative of x squared, we'd still start at 0, 0. But when we go left 1, we'd go down 1. And go left 2, we'd go down 4. And you go left 3, and you go down 9. So are you okay with that? That's really the big idea for the day is just a positive x squared goes up, a negative x squared goes down. And then the final thought is this, and this is the one that I want you to write down. Like, come hell or high water, this is the one thing you need today. I'm going to put some line segments up here that are yellow, and I want you to memorize something about them. Uh, can you see that little yellow? And this one, and this one. I need you to help me memorize the lengths of those yellow segments because we're going to use them on every single problem today. There's a shortcut, and the yellow is the shortcut. How long is the first yellow growth? 1. So when we go from the vertex of the graph out 1, so if we go out 1, we go up 1. See what I mean by that? It's like you leave the vertex and you go sideways 1, you go up 1, boom, you got a point. What is the next length of the yellow? So we can say that if I leave the vertex and go out 2 units, left or right doesn't matter. I go up 4. What's the final? And there's more, obviously. I just don't have a big enough piece of graph paper, but the last one is 9. And so that means that if I leave from the vertex and go out 3, I'm simply going to go up 9. And that's huge because then I mean, watch how slick and easy this is. I'm going to erase a bunch of stuff here, but I just want you to see how beneficial that information is. So let's say I asked Justice to make me the graph of a parabola, and I told her that the vertex was right here. I was like, there's a vertex right there. And I said, oh, by the way, I wanted to go downhill. Justice doesn't have to go and make a table like we did. She doesn't have to do math. All she has to do is go out 1, down 1. Out 2, down how far? 1, 2, 3, 4. Justice goes out 3. How far down does she go? 9. So you see, that's the powerful benefit of memorizing those numbers. I'm going to put little red circles around them over here, or I'll put a red box around them. Those numbers, 1, 4, 9, those are huge because they're what we use to build points off of the vertex. Got it? What would be the number after 9? Just curiosity. If I had a big enough piece of graph paper, 16. After that, 25, 36, so on and so forth. So, but rarely do you have enough graph paper space to worry about that. And I think on today's Delta Math is just going to ask you to graph, I think, a total of 5 points, maybe 7. So you have vertex and then boom, 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 and you should be good to go. Final question is this, and this you need to write down. This is big. The final big question is this. Where is the vertex? Because the vertex is going to move around, right? That bottom point or top point of the graph is going to move around. And the formula that you're going to use to find it is right here. I'm going to write it in purple ink, and I'm going to write it relatively large, and I'm going to be as generally neat about this as I can. And I want you to write this down. You will use this formula on every single problem today and probably Monday. You know A and B, there are guys. So let's say I made up a quadratic like x squared plus 4x minus 2. And I said like y equals. So this is it. We're doing one together right now. And I said, hey, Hannah, I want you to graph this parabola for me. She could do it, but her only dilemma would be, Mr. Hannah, I don't know where to start. And that's what the purple formula does for us. So in this quadratic equation that I've given Hannah, what is A? You know this from the quadratic formula. What is A? It's right there. Good. A is 1. What's B? 4. Or is everybody at peace with that? We don't care about C for the record. So it's like it's there, but we don't need it for the little purple formula or the big purple formula, right? So if Hannah's going to go now and find her vertex, she's got to calculate the answer to opposite B over 2A. She could easy, light work. What's the opposite of B? So she's going to write -4 over. And what's 2 times A or 2 times 1? And what is -4 divided by 2? So Hannah now knows for a fact that her vertex is at the point -2 comma blank. But she's like, that's still not enough information. Like, thanks, but really, that leaves a lot of possible places for me to put my vertex. Can you guys think of a way that we could figure out how to finish off what the rest of the vertex is? If we know that the x coordinate of the vertex is -2, do you think we can find the y? By putting -2 right there and right there. And by May 15th of your ninth grade year, I would say that that's a pretty simple task, right? So help me out with my math. If I put -2 in the first, I'll point it to it with a yellow arrow right there. Turn that x into a -2. Just use your head. You don't need a calculator. 4. -2 squared is 4. Now take a -2 and put it where the other yellow arrow is right there. And that is -8. And what is 4 minus 8? And what is -4 minus 2? Hannah is now the proud owner of the knowledge that her vertex will be at the point -2, -6. Have I lost you? Then all she's going to do is go like this. She's going to go to the point -2, -6, and put a dot. And how is she going to find all the other dots? Remember the pattern? She's going to go out 1, up 1. Boom. She just found 2 more points without doing any math. She's going to leave from her vertex and go out 2. How far up is she going to go? 1, 2, 3, 4. She's going to leave from her vertex and go out 3. How far up is she going to go? She's going to go up 9. And she actually has room to do the 4 because she actually has enough room to go up here to 16, just FYI. So that's how you graph a parabola. And if there'd been a negative in front of it, then she would have just done all the same stuff, only it would have been pointing downwards. So let me transition over to Delta Math, and you guys can help me with, you can kind of coach me through what it's like, the process, what it's going to look like. Okay. So let me get over here. Let's see, third hour, graphing parabolas, skills, level 1. So here we go. And I'll zoom in just a reasonable amount, and you guys are my guide, my assistants. So someone says graph that equation up there at the top of the TV. What's the first thing we have to do? Find the vertex, find the vertex, find the vertex, right? And that little formula, you're going to carry it around in your back pocket. It's never going to change. If you take algebra 2, it's not going to change. It doesn't matter. It's just never going to change. It's always the opposite of B divided by 2A. So in this case, yeah, and I'm just going to slow down a little bit because I don't want to lose anyone at all, Cal, but you're exactly right. In this equation, I hope we all agree that A is 1. It's right there in front of x squared, right? And B is -2. And Cal very astutely noticed that if you do the opposite of B, it becomes a +2. And what is 2 times A? And what is 2 divided by 2? So we would know in a problem like this now that the vertex is at 1 comma blank. We don't know, do we? How are we going to find the y, the other half of the vertex? It's definitely positive one because it's 2 divided by 2, right? So we're just going to go up to where all the x's are and we're going to change the x's into ones. So like right where these red arrows are pointing, you're going to put a 1 right there and you're going to put a 1 right there. The math should not be difficult. What's 1 squared? 1 minus what's 2 times 1?
Or two.
2. And what's 1 minus 2?
One.
What's 1 minus 2? Negative 1 minus 8 is negative 9. And so what delta is going to have us do now is make the graph. And so as long as I know my vertex, I am in like Flynn. So I'm going to go to 1, negative 9, and I'm going to make a dot like this. And now it's just going to say you need to have 5 points, including the roots and the vertex. And the roots are going to be the places where it crosses the x-axis, but sometimes those will take care of themselves. So here we go. I'm going to zoom in for you a little bit more now. I hope you're not super lost. Here we go. When I go, see me moving my mouse here. When I go out 1, how far up will I go? Good. And I'm going to do that on both sides. When I go out 2, how far up do I go? 1, 2, 3, 4. Now it says 5 points, but you also have to include the roots. I have a sneaking suspicion if I submit this, it's going to tell me that I'm wrong. And I'll tell you why so you don't get frustrated. So I'm going to delete these 2 points right here. Well, here, just watch. Submit answer. It's going to say no. We didn't do anything wrong. What we did is we didn't graph these 2 points right here. Let me make some big red dots on them. It needs you to actively, and it's only going to let you click 5 dots. So vertex takes 1, out 1, up 1 takes 2 more. And then those other ones, what I should have done is I should have skipped these ones that I'm circling, and I shouldn't have wasted my 2. Kind of looks like a happy face. Hello. I should have skipped the 2 eyeballs and I should have jumped up and saved my 4th and 5th points for these ones because it's asking you specifically to always make sure that 2 of your points are the ones on the x-axis where the graph crosses through. So let's do one more and I'll show you what that means. And then I swear I'll shut up. I will. Laughing at me like you don't believe me or something. Let's go again. Um, yeah, heck yeah, Cal. It's going to be upside down. So let's do this thing. What's A? It's not. It is -1. What's B? Good. And so you listen, the math I'm asking you to do is so not hard, but it still gets messed up because we're humans. So just try not to be a dinker donker. And again, yes, Cal, the opposite of B is 4, and we're going to divide it by 2 times A. What's 2 times -1? Remember, it's negative B over double A. And what's 2 times A? What is 2 times -1? -2. And 4 divided by -2 is, so the vertex is at -2, comma something. Are you with me?
Yes.
Because you're going to have to do this by yourself in just a few minutes. You good? Now, what are we going to do with that -2?
You're gonna put it on the next box.
Oh, crikeys. Yes. So we now know that the vertex is at -2, comma blank. So this little red circle is going to become a -2. And this little red circle is going to become a -2. And this is a harder one. It's going to say the negative of -2 squared minus 4 times -2 minus 3. I'm showing a little bit more work on this one because, as you can imagine, I bet normal people would want to put those negatives together to make a positive, right? Don't do that. Order of operations says you're not allowed to. What you have to do is what's in the purple square first. What's -2 squared? +4, but then that negative comes on and makes it -4. And then this part right here, this big oval, what's -4 times -2? +8. And now we just have to do like some 3rd grade math. What's -4 plus 8? 4. What's 4 minus 3? Hey, guess what? We know our vertex. That's huge. -2, 1. All the work is done, and now all I have to do is just go cash it in. So -2, 1, I'm going to move my mouse. I'm going to go left 2, up 1, and go clicky. Boom. And you said it. The graph opens downwards, right? I don't have to worry about the whole roots thing this time because guess what? If I go out 1, how far down do I go? And look, I just used 2 of my dots to make the roots, so I don't have to stress over that. Nothing wasted, but I do need a couple more dots. So I'm going to go out 2. How far down will I go? 1, 2, 3, 4.
Oh, wait, no.
Look, done. And this time, if we submit it, it's going to like it because we purposely plotted the 2 points on the x-axis. So I've well past the time that you're supposed to talk to people without expecting them to fall asleep. So grab out your old Chromebooks. Let's try some of these on our own. Oh, yeah. So this is what I was hoping for is Peyton's right in the middle of this problem and he's down there and you can see that he graphed his vertex and he graphed his out 1, up 1. What's going to be the problem if you were paying attention during the lecture, you know,
Oh, it's not gonna reach.
it's not going to get to the points that Peyton needs. It's going to, so like if he goes out 2 and up 1, 2, 3, 4, I, as your math teacher, don't have any issue with those points, but Delta Math is going to cry foul. What does it want him to do? It wants him to do the 3 nines because Delta's pretty picky about this. It says, I need you to graph the points that touch this x-axis. So Peyton's going to skip his 2, 4 combo and he's going to go out 1, 2, 3 and up 9. And he's going to graph these 2 big red points right here. Oh, wait, I went over too far, Peyton. No, I didn't. Oh, Peyton, please don't trust me. I'm doing something wrong here. Okay, Peyton, let me reset my dumb brain. So out 1, 2, 3. You had it, buddy. And then out 1, 2, 3. There you go. Yeah, clearly I've never done this before. So now if you select those points, then it's going to be happy because you have your 5 points and you specifically graph the ones on the x-axis. So 1, 1, 2, 4, 3, 9. Those are your combos.
Yeah.
You better?
Yeah.
Rad.
Thank you.
You bet. Yeah, Jackson. You bet.
Good job. What? Good job. Thank you.
So Jackson, yours is one of the really hard ones because it's got the negative in front of the x squared. So first off, what is your a value? Good job. And what's your b value? Okay, so when we do our little happy formula, our opposite of b divided by 2 times a, what's the opposite of b? Okay. What's the opposite of b? That's the purple formula. Yeah, so the opposite of -10, so we're going to put +10 over. And what's 2 times a? And what's 10 divided by -2? 10 divided by -2.
Oh.
Yes. So here's what your vertex currently looks like. In fact, I'm going to leave it as the only thing I've written on your screen as the vertex. And unfortunately, that vertex is terribly incomplete, right? So what we're going to do is we're going to plug that -5 back right in where these tiny little red arrows are pointing for you. You're going to put a -5 right here and right here. And this is why your problem is harder than the one I just did with Peyton, because his didn't have the negative. But see this negative out in front? Ah, man, he's a killer. So what you do is you take that negative and you kind of put it in a timeout and you just do this part in the red jelly bean right here. Can you see the little red jelly bean? So help me with my math. If I put a -5 in there and I square it, what is -5 squared? It's exactly like a +25. But here's the problem. You get that jelly bean becomes a +25, but then that negative that I was pointing at with the downward arrow actually makes it become, again, -25.
Right.
So like squares to become a positive, and then the negative in the front is like, sorry, I'm annoying, but I'm going to make it a negative again. And then the second part of it, I'll draw a purple jelly bean. or whatever that is, kind of jelly bean. What's negative 10 times negative 5? Negative times a negative is a positive, and what's positive 50? 10 times 5 is 50. And then you have a minus 21 at the end of your equation. So we're just going to take away 21. So now I'll help you with the math. Negative 25 plus 50 is positive 25. And 25 minus 21 is hallelujah. Guess what we just did? We just figured out that your vertex for your parabola is at negative 5, positive 4. Now, move your mouse over and click on that point. Now, is this an upwards opening parabola or a downwards like an arch? No. I know that's a 50-50 question, and if it's not one, it's got to be the other, but I want to draw your attention to something. See that negative right there? That means the graph is going to go this way. Got it? Negative makes it look like that. So, good point so far. Good points. And that those are perfect because you got your 5 points and you also happen to get the ones on the x-axis. So you're good to go. That negative in the front is a whooper, so watch out for him. He's going to make that x squared part turn negative. Okay, good.
Yeah, this, the like algebra 2, instead of just x, are you gonna start adding numbers to the arm?
Yes. Yes. All right, so we'll work on this some more on Monday. Got it?